Today we are going to talk about normal distributions. It says normal distributions have the shape of a bell curve, and the area under the curve represents probabilities. It tells us that our mean, and the symbol for that is x bar, and the standard deviations work as follows. You're going to want to draw this picture into the top margin, so at the top of your paper where there's some room. You can't see that on my screen, so I'm going to draw it off over to the side under question 2, but you'll want to leave that space for when we actually do question 2. But at the top of your paper, you're going to want to draw what a standard deviation actually looks like. So a standard deviation looks something like this. It should be symmetrical and ever decreasing along the sides to an asymptote. Exactly in the center at the highest point is where our average exists. And then we count out to each side of the average by a standard deviation. So if I go one standard deviation out away from the average, it says that that should encompass 68% of the data. So what that means is, if I did a survey of 100 people and asked them, how many hours of sleep do you get a night? And I found the average of that, or the mean. That would go right in the middle there. Then I would find the standard deviation, and I would count that many minutes away from whatever that average number of sleep was. Count that much out to the side, and if it's normally distributed, 68 out of the 100 responses should fall within that range. So the bulk of data falls within one standard deviation away from the average. Then as we go out to a second standard deviation away on each side, that's going to encompass 95% of our data. And as we go on out to that third standard deviation away on each side, that's going to hit 99.7% of our data.
But it'll never reach 100.
Technically not, because it never does truly close off, but we're going to say that anything beyond that third standard deviation is 100%. But you could always have one crazy outlier. One end or the other. But we're going to say if it's beyond 3 standard deviations that it does include everything.
Are these just examples, or is this like a set?
This is a set rule that for a normal distribution, this should always be true. Not all data is normally distributed, but if it is normally distributed, which a lot of data is over a large population. So if you took a large survey, a good cross-section of population, then many things would be normally distributed. Okay, so our rule is 68, 95, 99.7, and the curve is completely symmetrical. So for question 1 then, what we're going to want to start by doing is drawing out our curve. So we are told that a survey of shoppers in supermarkets said that they have a mean or average amount of time spent in the store of 45 minutes. So right at the peak should be 45. Then we're going to count out our standard deviations to each side. The standard deviation is 12 minutes. So if I go 12 minutes away from 45 minutes, that puts me at 33 minutes and 57 minutes. So one standard deviation away on each side. Our second standard deviation, count out another 12 minutes, which would give me 21 and 69. And then counting to that third standard deviation, we get 9 minutes and and 81 minutes. That 9 is kind of hard to see as it's falling off the paper, but that's a 9 past the 21. So when you have a question, you're going to want to start by drawing out your curve with your standard deviation values there away from the mean. Then, in part A, it asks us what percent are going to be between 33 and 57. So 33 and 57, when we look at our graph, are one standard deviation away on each side. So what percent are supposed to be within one standard deviation? 68%. So 68% of shoppers spend between 33 and 57 minutes in the store. Part B, what is the probability that a randomly selected shopper will spend between 45 and 69 minutes? So then we're looking at this section over here. Well, 69 is how many standard deviations away? 2, but only in one direction from the middle, and it's still centered around the middle there. So if I did the whole thing 2 away on each side, how much would that be? 95% according to the rule. So it says that 95% lies within 2 standard deviations. But we only have from the middle out in one direction, but our curve is symmetrical. So what does that mean about from 45 to 69? You can divide by 2 and get 47.5%. Now in this question, the way that it's worded, it says what is the probability, as opposed to part A said what percent. I don't care if you leave your answer as a percent, that doesn't bother me at all, but just so that you know, if you go to check your answers in the back of the book, when they use the word probability in a question, they're going to turn it into a decimal. So they would turn this answer into 0.475. Probabilities are supposed to be numbers between 0 and 1. We often turn them into percents, but technically a probability is a number between 0 and 1. So I don't mind if you leave it at the percent, but just know if you go to check your answers, that's why some of them are decimals and some of them are percents. Okay. Questions? All right, so for number 2 then, we want to make our graph. The mean is $36, and our standard deviation is $9. So we're going to count away by 9s. For part A then, what percent were located between 18 and 72, which goes off the edge? So we're going to say from 36, the middle, out to past the edge is 50%. Okay, so if it goes more than 3 standard deviations away, we're going to say that covers everything. So from 36 on out past our third standard deviation of 63 to 72, we're going to say that's 50%. 18 to 36 is how many standard deviations away? 2 in one direction, so like the last question, that's going to be 47.5%. 2 standard deviations away in both directions is 95, and since it's symmetrical, in one direction would be 47.5. So if I have 47.5 from 18 to 36 and 50% from 36 onward, I can put that together and say that it's 97.5%. Questions on part A? Use the symmetry of the graph, and we'll do more examples that'll be like that. So part B, what is the probability that a randomly chosen pair is between 9 and 18? So this is off to the side, doesn't use the middle at all. I want to know what chunk is between there. Well, 9 is how many standard deviations away? 3. So if I went 3 in both directions, how much would that give me? 99.7. And 18 is 2 away. So if I went 2 away in both directions, how much would that give me? 95. So then I have these 2 little wings here, the one that I care about and the matching one over on the other side. What's the difference? So how much is left for those 2 little wings? 4.7. So we would take the 99 0.7 minus the 95 gives us 4.7 left over for those two little wings. But this question only asks about one of those wings. So then what do I do? Divide by 2, because the two wings should be the same size. So divide it by 2 gives us 2.35%. Or, since this question said probability, the back of the book is going to give your answer as 0.0235. Okay, so we look at our boundaries there, and we subtract our boundary values to figure out how much should be on both ends, but if we only care about one end or the other, then we would divide out by 2 because of the symmetry. Questions? All right, for number 3, some height statistics. It says the height of men in the United States is normally distributed with a mean of 69 inches and standard deviation of 2.75. So the mean goes right in the middle, and 2.75 more than that is 71.75. I actually don't need to create the whole graph here. If I read ahead to the question, the only thing I care about is 71.75. So you could, but we don't really need them because the only thing it asks about is 71.75. So we might as well not bother doing all the other additions and subtractions. So our question says, if we randomly choose 3 adult men, what is the probability that all 3 are 71.75 or taller so that they fall into this region? So we need to know what is the percent in that region. Well, from middle out to edge is what? 50. And 71.75 is 1 standard deviation away, but only in one direction. So how much is between the middle and 1 standard deviation away in one direction? 34%. It's 68 going in both directions. So in just one direction would be half of that. So how much is that little tail that we're asked about? 16%. We can subtract. If 50 is from the middle on out and 34 is that little region we don't care about, then 16% would be the region we do care about. So there's a 16% chance that a adult man, one single adult man, is going to be taller than 71.75 inches. Our question asks us, what about 3 men? So if I randomly select 3 men, what's the chances that all of them are in there? Another way of wording with this would be, what is the probability that I find one adult man and then another one and then another one? And when we use the word and in probability questions, we are going to multiply. So I'm going to multiply that the first guy has a 16% chance, but turn it into a decimal. And times the second guy has a 16% chance. And the third guy has a 16% chance. So when we want to know about more than one event occurring, we are going to multiply those probabilities, 16% for each of them, and multiply those together. So 16% times 16% times 16%, but always make sure you turn it into a decimal first. Don't do 16 times 16 times 16. So 0.16 to the power of 3 then is 0.004096. And you can just leave it right there because it says what is the probability. So that's actually how the book would leave it. But if you're more inclined to do percents, then you would say that it is a 0.4096% chance. If you're changing it to percents, make sure you use your percent symbol, because otherwise I won't know whether you just got it wrong or whether you meant to do a percent and forgot to use the symbol. Okay, because they are different numbers then. So it is not very likely that we are going to randomly select 3 men and have them be that tall unless you live in West Michigan. West Michigan is above average for height compared to the rest of the nation. But if we look at the country as a whole, it's not very likely. Questions on these 3 problems? last question talked about buying strawberries. When you go to buy a box of strawberries at the store, it's going to be on a package that'll say that it's 16 ounces. Okay, 1 pound is the standard size packaging for strawberries. But not every package is actually exactly 16 ounces because they're not going to sit there with like whole barrels of strawberries and be like, let's try this one. Nope, that makes it a little bit too much. Okay, let's swap it out for a little bit smaller. Oh, no, that's not enough. Right, they're just going to fill up the box of strawberries and say close enough, right? But how close? So it says the average is actually 16.18. So really on average, you're getting a little bit more than what you're paying for, but not always because sometimes you'll be lower than the average and sometimes higher. So we're going to create our normal distribution curve. So 16.18 is average with a standard deviation of 0.34 ounces. Now again, we could do the whole chart, but if we look at what we're asked about 15.5. So I'm just going to head towards 15.5. One standard deviation away, if I do 16.18 minus the standard deviation of 0.34, that puts me at 15.84, and one more standard deviation would put me at the 15.5 that we're asked about. So our question asks us, if I randomly select 2 of the containers, what is the probability that both of them are less than 15.5 ounces? So what's the probability that I'm like really kind of missing out on what I'm paying for here twice? So we need to figure out what probability lies in that little wing. Well, all the way over from the middle would be 50. 15.5 is how many standard deviations away? 2. And how much should lie within 2 standard deviations? 95 going both ways. So going one way would be 47.5. Okay, we did that calculation on the other side as well. So how much is left over for that wing? 2.5%. Okay, so we have a 2.5% chance of getting a box of strawberries that is less than 15.5. But our question asks us, what is the chance that that's going to happen to us twice, that I select 2 boxes? So 0.025 for the first box, 0.025 for the second box. And we multiply those together. To get 0.000625, the graphing calculators will actually give that to you in scientific notation. It's going to say 6.25 times 10 to the negative 4, or e negative 4. So you'll need to make sure that you adjust that decimal. So since the question says what is the probability, we can just leave it right here at the decimal, but if you wanted to, if you're more inclined to percents, you can change it to the percent, but just make sure you use your percent symbol. So once again, not very likely that this is going to happen to us, that we're going to get kind of ripped off twice. Right. Questions? All right, your homework is from 12.7 tonight.